Hello everyone and welcome to this class. In today's class we're going to talk about the representation of a journey on a distance time graph. I am Oba Isaac Ebuka. By the end of this lesson, you should be able to define distance and speed, construct a distance time graph from given information, and for the high tier student learners, you should be able to determine the speed of the object. But before we proceed, we have to have a refresher on distance and time. What is distance? Distance is the measure of the length between objects without regard for direction. Remember that distance is not the same as displacement, as displacement have to do with the direction. The SI unit of distance is in meters, denoted by a lowercase m. And what is time? Time can be defined as the magnitude used to quantify the duration of events. The SI unit of time is in seconds, and we denote it by a lowercase letter s. Now, let's talk about the steps that we have to take when we are given a problem to solve concerning distance time graphs. So the very first thing we do is that we draw a Cartesian plane for the representation of the journey. Then the second would be to label the axis for the distance and time correctly with corresponding units. Then we carefully read and understand the question so that we can represent it on this. So this is example distance time graph, and we're going to be explaining what's going on in this graph. So the very first part of this journey, which is here, shows that the object is traveling at constant speed. This means that equal distance is traveled in equal time. Then the second part of this journey, where we have a horizontal straight line, it shows that the object is stationary. Whenever you see a horizontal line on a distance time graph, you know that the object is stationary at that point. Then for the last two parts, there is changing speed. The very first one being this is the acceleration, while the second one is deceleration. Acceleration means an increase in speed, while deceleration means a decrease in speed. Now, this is an example for us to do. A boy walks 40 meters in 20 seconds. He then walks a further 10 meters in 30 seconds. Represent this journey on a distance time graph. So remember that, like we said, the very first step to take is to draw a Cartesian plane. And this is the distance axis, while this is the time axis. And the second step would be to label the axis correctly. Distance is in meters, while time is in seconds. Now, we have to represent this journey on this distance time graph. So since the boy walks 20 meters in 20 seconds, we have to look out for the place where these numbers coincide in our distance and our time axis. So 20 meters in 20 seconds coincides at this point. 20 meters and 20 seconds. Then he walks another 10 meters in 30 seconds. So we add another 10 meters, making it 30, and we also add another 30 seconds to 20, making it 50. So our point will be here. Then finally we connect the dots with a straight line. So we'll do that starting here, and also we connect this one as well. So now we've represented this journey on this distance time graph. Now this is an example for you to do. John Smith took the B bus to Manchester Piccadilly and travelled 10 meters in a straight line in 5 seconds. Then the bus stopped for 5 seconds to pick up another traveller and then travelled another 20 meters in 10 seconds. Represent this journey on a distance time graph. So we represent 10 meters that he has travelled in 5 seconds, which coincides at this point. Then, according to the question, the bus stopped for 5 seconds to pick up other travelers, and so we're going to represent this on this distance time graph. So we count 5 seconds from the initial 5 seconds traveled, which is here. So, and notice why we didn't go any way upward is because the John Smith is stationary. Now for the final journey, he travels another 20 meters in 10 seconds. So another 20 meters should be here, and another 10 seconds should be 10 seconds away from the first 10 seconds. We should be here. Now we have to connect to this point to form our distance time graph. So we connect the dot starting from the origin . And this. So this is the representation of the journey on the distance time graph. Now here is your take-home assignment. So write the description of the journey represented in the distance time graph below. The distance is in kilometers and the time in hours. Note: remember to convert the distance and the time to SI units. Thank you for your rapt attention.